Hi and welcome to this video for the BTEC Applied Science Level 3 course. What we'll be doing here is looking at Unit 19, Assignment 1 and walking through the specification for what you need to include within your assignment. So as we can see at the top here, we've got two pass criteria, 2 merit, 1 distinction, and I'll try and pick out where they are for you and exactly what you need to do. Now, P1 on the assignment brief says demonstrate accurately the amount of analyte in matrices. Now, what this is referring to, if we highlight in here, learners will accurately measure the percentage composition of copper in a sample of brass, hydrogen carbonate in water, and percentage of iron in a commercial iron tablet. So learners will carry out practical work independently following standard methods provided by tutors, demonstrate competency, yada yada, evidenced by a report. So results will be reasonably accurate and they may be evidenced by comparing learners' results with those of their classmates, or if you're just giving the true results for what should be in there, then you can just compare with those. So if I mark up here, this area is P1. You're going to be doing 3 practicals, plus the associated calculations with them, which if you continue with the playlist on this YouTube channel, you should get an idea for how to carry those out. So fairly straightforward there, classwork, bit of calculator work afterwards, couple of 2 or 3 graphs, if I remember right off the top of my head, need to be drawn with obviously the colorimetry, the calibration curve, and you need the pH 1 for the hydrogen carbonate. The other little bit here down at the bottom, this is P2. So P2 says describe the composition of the matrices analysed. So this is a pure research task, and as it says explicitly, you must reference where you are getting the information from. So P2 is basically what's in brass, give a reference, what's in the iron tablet, give a reference, and what's in bottled water, give a reference. So the bottled water will contain many different ions within there. Obviously one of them would be the hydrogen carbonate ion, and yeah, brass is a mixture of copper, zinc, sometimes some other things in there. Again, you should have 3 references for these 3 matrices that you're looking at. If you do not include them, then you'll not be hitting this part, and it's often just a lot of laziness where students need to constantly resubmit this pass criteria just by not providing a reference. So further up onto the merit bit. Merit M1 is discuss the measures taken to ensure accuracy in determining the amount of analyte in the matrices. So what we need to have up here is where we are going to have discussing good volumetric practices, why you've repeated work if needed, mark that. This bit in here, you should have hopefully done this in your Unit 2 Assignment 1 practical last year. Generally, a lot of it you can just pull out and reuse. So in terms of when you're carrying out titrations, things like when you're measuring out from the burette, you do the rough and then you know where to stop for the next time. So kind of going slowly before that, going drip by drip. When you're doing the colorimetry, making sure not to put your fingers on the side of the cuvette that's going to have the light shining through it so that the light isn't absorbed by that and you end up getting incorrect readings. So I'm not going to repeat that too much. Generally, just look back at your old work and you should be able to repeat that. Obviously, try and make it specific to this practical that you've done. So for example, the pH probe that you were using? Is there a better instrument that you could have? And M2 next down it. So M2, compare the use of primary and secondary standards. So they will explain why secondary standards are used in preference to primary and why the secondary standards must be standardized using primary. Now, a primary standard is what you make up from a solid initially. So for example, in the water titration, where you're working out the sodium hydrogen carbonate, lab tech would have used sodium carbonate initially as the primary standard. It was weighed out and the solution was made up. I think it was 0.05 moles per decimeter cube. And then hydrochloric acid was standardized using that. So the HCl was a secondary standard in this case. And then the HCl was used to titrate the sodium hydrogen carbonate and allow you to work out the concentration of that afterwards. What we need in here is some discussion about what primary and secondary standards are, and again, why the secondary are used in preference to the primary. So why, for example, didn't you just react the sodium carbonate with the sodium hydrogen carbonate? And likewise, up in the other practical, why you use the potassium manganate in preference to some other chemicals for the redox titration with the iron. Now I've included a link below in the description for a very good PDF that I found on the internet. Use it, basically. It's got all of the answers you need pretty much within it. Make sure to reference it appropriately, or if you find other sites, and again, referencing is key. Now, up for the distinction bit, there's only the one criteria D1 up here. To analyze specific features of the three methods that may affect results, they will consider why the results from these experiments may be different from where techs made solutions of pure compounds for analysis. Now, don't just say the tech is better than you. That's not really what this is hinting at. You were using different chemicals to what a tech would be using if they were using pure compounds. That's the key word to be thinking about here, not just that the tech's better than you. If the tech used pure, what were you using and why would it give different results? So try and think about if the chemical you were using, it may not just have been one part of it that would have been reacting. What would happen to your results if there were other things within, say, your iron supplement tablet that were going to react with the potassium manganate? How would that affect your results? And what would that make you think about the amount of iron that was actually present in the tablet? That's what it's hinting at up here, what it wants you to discuss. So distinction, what can go wrong essentially in the practical that would affect the results and make you think they were a different value than what they actually were. Okay, thank you.